Okay, welcome back everyone. Again, I had, I hope everything's working now. The YouTube says everything is live, everything is good. So today I do want to keep it slightly shorter than usual, actually maybe significantly shorter than usual, maybe we'll do half a stream, and because there's just a lot going on. However, I did not want to cancel. We'll try my best to really keep the schedule. So let's pick up where we left off. So here we were, let's just see, and we had left ourselves some notes. Let's see, let me just check. Yes, this is the. Okay. Is this okay? Yeah. All right. So this is what. So we had. We had generated heat maps from all the tools. Let's just bring that up again. Okay. Apparently I'm still running this on some. Okay, I'm probably still running this on some. Oh, I still have all of these things open here. Okay, actually, let me do this. Yes, I still have everything open from last week. So this is what the problem was. Okay, so, alright, so, Okay, so sorry about that. So then I still had everything. I still had the, and NeoVim, like Vim actually, complains if you try to open the same file two times. So, okay. Okay, I need to be in the source directory. Yes. Okay. So I guess this is part of trying to get back into it. This is what we had done. We had generated these plots, just to remind everyone. So we loaded the data. So we spent some time last week working through the how to take this code that we had generated that was sort of very linear, hacky code, and making it into a function that can be reused. Then we count the frequency, and we select those genes that are present between 20 to 80% of the time, and we plot in the heat map. So we had discussed how to do these things, and the output was, let's see if this is, the output were these maps where you can see that once they pop up, there is some blocky structure there. And we said, okay, today let's start looking at this blocky structure. And we are going to be looking using the arrow, the antibiotic resistance ontology, and that is very easy in the case of the RGI output, because arrow is done by the same group that creates card, and card and arrow as well. And so in this case it's very easy because all of the RGI genes are already card annotators, right? So to do that, alright, let me just remove all of these things, and let's get actually that's okay. Let's say, for example, we have this. So here we see we have these genes that use this nomenclature. And now we want to link this to arrow. So the first thing I'm going to do, arrow ontology. I'm going to look this up using the web interface. So the EBI has this web interface. I'm going to search. Yeah, there it is. Okay, so in this case, you can see that's an aminoglycoside targeting gene, or so it's a gene coding a protein that is an aminoglycoside modifying enzyme. So what we will just skip those logical steps and say it's a gene that it targets aminoglycoside. Okay, so we could do this like this, where we could copy each one. Okay, and this. Okay, it's another aminoglycoside, which perhaps not surprising given that it has more or less the same name. But what we're going to do is we're going to use Pronto, which is ontology, which is a Python library for ontology. For ontologies done by this great guy at who used to be at the MBL. I don't know where is he now? Is he still at the MBL? Yeah, Martin. Yes, at the MBL. Yeah. I mean, everything he's done is excellent. So if you any of these tools that Martin has put together, I mean, they're absolutely top notch. So we are going to be using Pronto. So the first thing we do is we are going to install it. Okay. And it's going to take a little while. And so Pronto is actually a generic ontology library. It has nothing to do with antibiotic resistance per se. So we are also going to be looking to find the arrow ontology OO file. Oh, there it is. It's here. Yeah, so this is the arrow ontology from cart. This is actually the official one. Arrow. Okay, but in the meanwhile, so Pronto installed. So let's actually first of all put it in the notes. Notes. Pronto. We also use Pronto. Putting here, just putting the notes together. And let's do some exploration, navigate, arrow. So here, let's just do some. So I need to start it. So first of all, I am going to just try to reproduce this operation that I did. So taking a gene name, getting an arrow object, an arrow term, and then seeing if we can see if it's what it is. So let's just see if we can do this in code. So I downloaded it. This is where I think I've seen this before. There's an issue with arrow. There's an issue here. Okay, this is a known issue. I think this is why we want to use the oboe file and not the arrow, or not the owl file. Okay, so this works. Let's just document this. Let's just also link to the pronto issue. Okay. Okay, so let's try to do the opposite. So, alright, so here, alright, so the keys look something like this. The keys look something like, oh, regulates, this is not, keys look something like this. Arrow, colon, number, right? And then if we index that, we get this term. So if we use that to index, we get the term. And then we have a name. So we can do a name term. Map back. see what did we have before. We had this, example this. Does this work? Yes, this works. Okay, so in principle everything can connect together. So we have the gene names. We downloaded the arrow ontology. We have the gene names. Now we map from the gene names to the corresponding arrow term. In this case, everything should work perfectly because RGI is using the card ontology, using the card database, which is fully annotated with the arrow, given that it's arrow was developed very close. It's the same group developing both projects, or probably sub-projects from a larger research agenda. Okay, maybe C doesn't exist. All right. And so now, and more importantly, we can get object the term so we've done this first step, which is the search, and now we're here. And now what I want to do is I want to go navigate using this confers resistance to antibiotic using Pronto. Actually, probably next week I'll try to show you that a lot of this functionality can be done using ArgNorm, but it's also nice to be able to do it quote unquote by hand, just sort of exploring. Exam. Right, so here. Okay, we can use superclasses. Okay. Okay, so we've made some progress here. All right, so we have. So let's merge everything, or not everything, but let's go to the. Oh, I see. Just get this read only. Copy some of this over here. No, I think we're not going to need this. But we are going to load it. Right, so we can map the columns in the data frame using to an arrow term. And so just by running the loop here, we just displayed it, but it also checked that all of these actually do map. Right, and so that's map. Okay, and so for today, so as I said, unfortunately, I don't have as much time as I wish I had. So I'm gonna do something a little just as basically as a sort of a still exploration, which is I'm going to look, and I remember that was this region here. No. This is after I filter for them. Okay, so I'm gonna get these. Alright, I just copy the code again, just getting this. I'm gonna copy the code here, all of it. Okay, close there. So, yeah, today I'm just a little bit. Alright, so this is what we had before. So okay, so we got that, and then everything as before. We copy the code here, build the counts matrix. Okay, and then that's gonna take a little bit. Okay, there it is. Okay, and what I want to look at is this cluster here. Yeah, okay, so it's okay. Reorder. Oh, okay, so the counts are just okay, yeah, so this is what we had last time. And now now just see the one. Okay, one of them. Right, that's right now I'm just exploring Right, okay, so right now we haven't actually done any progress so far, except that, so this is what we had at the end of last week with this list of genes, except that now we not only do we have the name, we have this weird number. So, you know, it's actually, so far it's actually hard to say that, oh yeah, this is so much better, because but now we're going to finally connect these things. Okay, and so you can see so much better, right? Maybe not, but let's keep going in this sort of completely exploratory. Okay, so here what we did is simply count how many times each term appears, and so we have a total of 19 because one of them didn't match. And let's look at the count. So we're probably interested in, so at the very top, so determinant of antibiotic resistance 19 times. Okay, this is completely uninformative. Let's remove that. Okay, and then it quickly decays. So we actually, in the end, these are the only ones that could have some efflux pump complex or subunit conferring antibiotic resistance. Okay, and 13 terms and 8 terms subunit of efflux pump conferring. Okay, so so it seems that we have here some efflux pump complex. All right. Okay. So we've made some progress. So we made some progress, and as I said today, I want to keep. I'm doing a half stream, so today actually for the first time I am going to be using the log branch. So the notes I want to keep. So the notes I am going to commit to the main repository. But this arrow exploration that we did, this one I actually don't want to. And yeah, and we'll do a bit of cleanup later. So yeah, so this is a particular, so this would be a good example of, so if I was working normally and then I happen to have something going on right now, I would have to abandon this project and I would not commit this code. I would literally just leave it here, but since we are doing this open, I now commit it to the log. Alright, so I'm going to do a short recap. I might actually break the tradition, and maybe do a second stream later in the week. Maybe 2 half streams adds up to a full stream. But for now, I am signing off, and I will see you next week.